I have in previous videos gone through the basics of programming. The next step once you understand the coding basics is to start using a coding mindset of coding using AI tools. This is a controversial topic, but let's face it, most companies use them and will require their developers to use them. In this video, I will help you think in the mindset of coding using AI tools and walk you through how it actually works in practice. This flows directly from my How to Think Like a Coder and Get Started Coding videos. If you haven't watched those, watch them first. Because everything you've learned there, variables, loops, conditionals, syntax, and the different kinds of errors, is what you'll use here. We are not replacing coding basics. We are building on top of it. What we'll cover in this video will be what actually changes when an AI writes the code and what stays the same, what CLI coding tools are and how they work, how to set a project up so the tool produces useful code, how to prompt for code, read what comes back and understand it, how to test and debug code written with an AI, and a brief look at DevOps, which gets its own video later. Let's get started. In the last coding video, you wrote a small program by hand. You typed out every line of the cake recipe yourself, in Python and then in Rust. That taught you something important. A program is just a set of instructions, carried out in order, with nothing left to sue. When you code with an AI tool, you usually don't type those lines yourself anymore. You describe what you want, and the tool writes the code. Then you read it, check it, and tell it what to change. That back and forth is the new way of working, and is how a lot of professional code is written today. A simple way to picture it is, in the last video, you were the cook, writing out the recipe step by step. Now you have a sous chef who can write the recipe for you. The sous chef has read every cookbook in existence and works very fast, but it has never tasted the food. It will hand you a recipe with salt, where it should say sugar, and it will look completely sure of itself while doing it. So your job shifts, it moves. You spend less time typing and more time deciding what to make, describing it clearly, and checking the result. And here is the part that matters for a beginner. To check the result, you have to be able to read it. That is why the fundamentals from the last video are not optional. When the tool writes a loop, for example, you need to recognize it as a loop. When it writes a conditional, you need to follow what it does. When it produces an error, you need to know whether you're looking at a syntax error, a logic error, or a runtime error. The AI does the typing. Understanding the code stays your responsibility, because nobody else is going to do it for you. You don't need to necessarily be an expert to do this. You need the basics you already have, and the willingness to actually read what the tool gives you and learn. The tools I'm focusing on here are called CLI coding agents. The main ones today are Claude Code from Anthropic, Gemini CLI from Google, and Codex from OpenAI. They work in much the same way, so what you learn with one carries over to the other. CLI stands for Command Line Interface. That's the terminal, the text window you saw at the bottom of the VS Code in the last video. These AI tools run there. You type instructions in plain language, and the tool works directly inside your project folder. The last part is what makes them different from typing into Claude or ChatGPT in a browser. In a browser chat, you copy code back and forth yourself. A CLI agent works inside your project. It can open your files and read them, write new code into them, run your program, read whatever errors come back, and try again. It repeats that loop, read, change, run, check. The same loop you would do by hand, just faster. Because the tool can change and run things on your computer, it asks permission before it does. Reading files is usually allowed automatically. Changing a file or running a command needs your approval. Different tools draw the line slightly different. Some can run in a sandbox that limits what they can touch. But the principle is the same. You approve the actions that matter. Leave that on. It is how you catch the tool before it does something you don't want or intend. A common early mistake, and I made it myself, is to open one of these tools and immediately type "build me website." You usually get messy files, a layout that's wrong, and code doing things you never asked for. The first habit that fixes this is giving the tool context before it starts. Every time you open one of these tools in a project, it begins with no memory of your project. It doesn't know what you're building or how you want it done. So you write that down in a file the tool reads at the start of every session. Claude Code, for example, reads a file called Claude.md. Codex reads AGENTS.md. Gemini CLI reads Gemini.md. Most tools are now also learning to read AGENTS.md as a shared standard. So in time, you can often write one file and reuse it. What you put in that file is straightforward. A short description of what you're building. 1 or 2 sentences. The tech stack, the language and tools the project uses. Even a simple website using HTML and CSS is enough. You also put in your rules, what the tool should and shouldn't do. For example, explain each change before making it, or keep the code simple and add comments. On a practical note, these tools don't always follow the file perfectly. It helps to add an instruction telling the tool to read it as a required first step and to confirm it has read it before doing anything else. The second habit is to plan before you build, rather than letting the tool start writing code the moment you describe something. Most of these tools have a planning mode that is read-only. The tool can look at your files and propose a plan, but it cannot change anything while it's in that mode. In Claude Code, you turn it on with Shift-Tab twice. Gemini CLI has a plan mode as well. Because these modes do not change anything, you can think out loud safely. The workflow is describe what you want, ask the tool to write out the plan before touching any files, and tell it to ask you questions if anything is unclear instead of guessing. These tools are built to make a best guess when something is ambiguous, and a guess is the last thing you want at the start. Then you read the plan, correct anything that's off, and only then let it build, ideally one small piece at a time, rather than all at once. Now look at this example. The things to notice from it. The AI tool asked questions instead of assuming, and it produced a plan you could read before any files were changed. There is a difference between directing the work and hoping it turns out well. Once you're building, the clearer your instructions, the better the code. The same framework from my prompt engineering videos applies. Persona, context, goal. Persona is the point of view you want the tool to take. For example, you are a developer who values simple, readable code. This mainly affects the style of what you get, worth repeating from the prompt video. Telling it to act as an expert doesn't make the code more correct. Use persona for the approach, not as a substitute for being clear. Context is what the tool can't know unless you tell it. What language and tools the project uses, what already exists, what it should avoid. Remember from the last video that code is extremely literal. These tools are a little more forgiving than raw code, but only a little. Whatever you leave out, the tool fills in by guessing. Goal is the specific thing you want it to produce, and this is where being precise pays off most. Compared to requests, make a login form gives you something generic. Make a login form with an email field and a password field. Reject empty fields. If the login fails, show the message incorrect email or password. It gives you something you can actually use. Describe the behavior, the inputs, the outputs, and what should happen when something goes wrong. Then there's iteration, which is normal, not a sign you did anything wrong. The first version is a draft. You read it and give specific feedback. Not make it better, which sends the tool guessing again, but the error message should appear above the form, not below it. Small specific corrections, one step at a time. This is the step beginners are most tempted to skip, and the one that matters the most. When the tool gives you code, read it. Before you accept a change, most tools show you exactly what they're about to add or alter. Look at it. You're not expected to understand every character. You're expected to follow what it's broadly doing. For example, this part reads the file, this part loops through them, this part renames each one. If a section doesn't make sense, ask the tool to explain it to you in plain language, line by line. This is not a waste of time. It is how you learn. Every explanation you read makes the next piece of code easier to follow. And over time, you'll find you can read most of what the tool produces. As I said in the last video, the explanation is part of your learning. The rule to hold on to: don't accept code you can't follow at all. If you can't tell what it does, you can't tell whether it's right, and you certainly can't fix it later when it breaks. Code that runs is not the same as code that's correct. Remember the logic error from the last video. The program baked the cake, nothing crashed, but it used salt instead of sugar. The only way to catch this is to actually check the output, not just that the program ran without complaint. So test it. Run it with normal inputs first, then run it with awkward cases. an empty folder, a file with no data, a strange file name. Those edge cases, as they're called, or where runtime errors show up. The kind that only appear when the program meets a real situation. For the renaming script, try a folder with one file, then an empty folder, then a file that already has a date in its name. You can also ask the tool to write tests for you. A test is just a small piece of code whose only job is to check that your code does what it should automatically. You ask the tool to write them, you ask it to run them, and you read what each one is checking, so you know what's actually being verified. I'll go deeper into the subject of testing in another video. For now, the habit you need to get is don't trust code because it ran. Check it does the right thing, and lean on tests to keep checking as the project grows. You already know 3 kinds of errors from the last video about coding. A syntax error where the program won't start, a logic error where it runs but the result is wrong, and a runtime error where it crashes partway through. That still applies. What changes is how you investigate them. When you hit an error, give the tool the actual error message and ask it to explain what went wrong in plain language and propose a fix. This is the same advice I gave for NLL in the last video, and it worked just as well there, except the tool can also see the surrounding code. It also helps to ask the tool to add logging while it builds. A log is a running record of what the program did and where it stopped. Like a flight recorder, you only need when something goes wrong. When there's an error, that's the first place to look. A few honest cautions, because this is where the sous chef analogy earns its keep. The tool can be confidently wrong. It can fix an error by hiding the symptom rather than the cause. And it can go in circles, changing the same thing back and forth. So, read what it changed before accepting it. Check that the fix addresses the actual cause and not just the messages, and work in small steps. Keep your project under version control so you can undo cleanly if a fix makes things wrong. I'll cover version control properly elsewhere, but even now, it's worth knowing it exists. And the same point from last time still holds. An error is not a failure, it's information. The computer telling you something specific about what it didn't understand. That's true whether you wrote the code or an AI tool did. One term you'll hear constantly, DevOps. I'm only going to define it here because it deserves its own video. So far, everything we've done runs on your own machine. DevOps, which is short for Development and Operations, is everything involved in getting working code off your machine and running it reliably for other people. Packaging it, putting it on a server, automatically building and testing it whenever you make changes, and watching it to catch problems. CLI tools can help with these tasks too. But it's a big subject with real consequences when it goes wrong, so I'll give it a full video later, rather than rush through it here. So here's the way of working, start to finish. Give the tool context with a briefing file. Plan before you build, in read-only mode, and make it ask questions instead of guessing. Prompt clearly, using persona, context, and goal, and iterate in small specific steps. Read and understand what it writes. Test that it actually does what you wanted. And when something breaks, use the tool to investigate but check the fixes yourself. Underneath all of it is one idea. The tool does the typing, and you stay the person who understands and checks the result. That's what keeps you in control instead of hoping. If you're new to this, do the same thing I suggested in the last video. Keep building small things. A script that renames files. A tool that sorts your photos. A simple page that shows a new picture when you click a button. A cute cat picture generator website, which I built in another video. Build it with one of these tools. Read every line it writes, and break it on purpose to see what happens. That's how this becomes second nature. If you have questions, drop them in the comments. If this was helpful, click the like and subscribe button. See you in the next one.